Have you ever watched a bird soaring high in the sky, making graceful circles without even flapping its wings? It's a beautiful sight, isn't it? For thousands of years people have looked up at eagles, hawks, and even tiny sparrows, and they have dreamed. They dreamed of what it would be like to leave the ground behind, to feel the wind under their own wings. This dream is woven into our oldest stories. Think of Icarus, who fashioned wings from feathers and wax. They studied nature, maple seeds, soaring birds, updrafts. Every gust was a clue. The sky was a giant science classroom and humanity was its most eager student. The idea of flight captured our imaginations. So next time you see an airplane streaking across the sky, remember, it is the result of a very, very old dream. Long before roaring jet engines, the story of flight was full of brave, brilliant, and sometimes wacky inventors. Tower jumpers strapped on wings and leapt, usually fluttering down. But each failure taught something vital. The first real step wasn't wings at all, but hot air. The Montgolfier brothers saw smoke always went up and made a balloon. Da Vinci sketched ideas. Sir George Cayley worked out lift, thrust, and control. He built successful gliders. On December 17, 1903, the Wright Flyer lifted for 12 seconds and flew 120 feet. The first sustained, controlled, powered flight. That tiny flight started a century of development. Balloons to biplanes to jets that carry billions of passengers today. World wars accelerated aircraft development. The first practical jet flew in 1939 and jet airliners followed in the 1950s. Supersonic travel peaked with Concorde and may return in new, quieter forms. If you look at an airplane, you'll see many parts, but every single piece has an important job. Think of it like a body. Every part works together to make the whole function. The wings are the superstar lifters. Their curved airfoil shape creates lift to hold the heavy machine up. The fuselage is the long tube for passengers, cargo and pilots, the airplane's body and skeleton. The tail, vertical and horizontal stabilizers, keeps the plane straight and stable like feathers on an arrow. Landing gear gets the plane on and off the ground. It retracts in flight to reduce drag. Engines, whether prop or jet, provide the forward push, the thrust the aircraft needs to go fast enough for lift. From wingtips to wheels, everything works in harmony. It's a symphony of science. How does a heavy metal machine actually get off the ground? It's physics. 4 invisible forces. Lift, the upward force created by the wings. Weight, gravity pulling the aircraft down. Drag is the air pushing back, like running into a strong wind. Thrust is the forward push from engines that overcomes drag. Imagine a tug of war in the sky. Lift versus weight, thrust versus drag. When balanced, flight happens. Bernoulli, faster moving air has lower pressure. Top of the wing has lower pressure than the bottom, creating lift. You can feel lift yourself. Hold your hand out of a moving car, tilt it slightly, and you feel upward push. To get enough lift, wings are large and planes move very fast. Engines supply thrust to make that possible. Wings create lift, but without a powerful push forward, they'd be just metal. The engines are the airplane's heart. There are propellers, jet engines, and emerging electric motors. All take in air and push it out faster. Newton. For every action, there's an equal and opposite reaction. Push air back, the plane moves forward. Propellers are spinning wings, efficient at low speeds for training and short trips. A turbofan sucks in air, compresses it, mixes it with fuel, ignites it, and blasts hot gas out the back to produce huge thrust. That backward blast pushes jets across oceans at hundreds of miles per hour. Now engineers develop electric engines, quieter, cleaner, ideal for small craft today and maybe larger aircraft tomorrow. Once aloft, how do pilots control the plane? They don't use a steering wheel like a car. Pilots use a yoke, or stick, and foot pedals, a control system of moving surfaces on wings and tail. Elevators on the tail change pitch. Pull back, the elevators tilt and the nose goes up. The plane climbs, push forward, elevators down, nose points down, plane descends. Ailerons on the wings move opposite ways to roll the aircraft. One wing drops, the other rises. That banking produces turns. Coordinated use of ailerons and rudder makes smooth turns. Foot pedals move the rudder on the tail to yaw the nose into a turn. A coordinated turn is roll plus yaw. Pilots are like conductors controlling the forces of flight. With training and tools including autopilot, pilots guide planes with incredible precision. Flying is safe because design, manufacture, and testing are unbelievably careful and precise. Engineers test wing shapes and placements in wind tunnels before cutting any metal. Materials, aluminum alloys and advanced composites, are chosen to be light and strong. Planes are built in huge sections in multiple factories, then brought together on final assembly lines. Robots and skilled technicians join parts with millions of rivets. Precision tools verify every fit. Wings are bent until they almost point to the sky to prove they won't break in service. Fuselage pressure, icing chambers, artificial lightning and door fatigue tests all simulate extreme conditions. Then, test pilots fly it through extreme maneuvers and thousands of hours of evaluation. Only after passing every test can an airplane carry passengers. Airplanes are more than vacation vehicles. They change the world, connecting people, cultures, and economies. They let families reunite across continents and let business and science collaborate globally. Air cargo delivers urgent goods, fresh flowers, electronics, medical supplies, fast. In disasters, planes airdrop food, water, and carry out medevacs, reaching places roads cannot. Research planes study weather, map the Earth, and monitor wildlife. Air shows and aerobatics inspire and entertain millions. From commerce to saving lives, airplanes are woven into daily life, quietly making the world smaller. They keep the wheels of our world turning, behind the scenes and above our heads. The story of flight is far from over. We are at the verge of another revolution in the sky. Engineers are designing cleaner, quieter, and more efficient aircraft for tomorrow. One big goal: large electric passenger planes powered by advanced batteries. Zero emissions between cities. Hydrogen and fuel cell concepts are another route to clean flight, with new fueling infrastructure ideas. Supersonic travel is returning. New designs are quieter and more fuel efficient than the Concorde. Blended wing bodies and radical shapes could make aircraft far more aerodynamic and fuel efficient. Urban air mobility, small air taxis and eVTOLs could whisk commuters above traffic one day. AI in the cockpit will help optimize routes, monitor systems, and assist pilots, making flight even safer. We might see hypersonic travel or space planes that reach the edge of space. Fast, daring progress. Whatever the shape, the future of flight continues the same human dream: curiosity, science, and daring. The sky is not the limit, it's just the beginning.